Well, good afternoon, everyone, and welcome to this GIRI forum. We're launching our new technology report, which looks at artificial intelligence and its potential to help in our efforts to reduce error. I must say I was quite a novice when it came to AI, but on reading this report, I've become much more familiar with the jargon and the definitions of the various types of AI. And I think it should become a must read for all in construction so they get an understanding of the impact it's going to have on all of us. I'm going to give a short introduction about GIRI for those of you who are not familiar with this, with us, and then hand over to John to give you an overview of the subject matter for the webinar. On the housekeeping front, please could you mute your microphones if you're not speaking, but turn them back on if you're invited to ask a question. And I remind you the session is being recorded. If you don't mind leaving your videos on, that's good, because that way we feel the meeting has more vitality. And use the chat box for questions and comments as we go through, which we'll pick up at the end of the session. And of course, if you have any tech problems, turn off and turn on again. That's the usual thing, isn't it, for tech issues? Leave the meeting and rejoin using the same link. Back in 2015, an ICE best practice group asked themselves the question, how much is error costing the industry and how much are we wasting? And the conclusion was we didn't know. GIRI was founded and obtained funding from industry to carry out a research project. And this is what we found. The overall wasted spend on error amounts to about 21% of turnover. There's the direct cost, 5%, indirect cost 7%. That's loss and expense claims and things like that. The impact on other people of making errors, unrecorded process waste. That's where errors occur, but they're not recorded. And then latent defects, with which we're all familiar. Now, at the moment, the GDP for construction's about 110 billion. So you can see this is a big lump, 21%. We looked at the root causes of error, and you can see the top 10 there. Design features in 6 of them, but the top one was planning. Late design changes, inadequate attention paid to design during the construction phase. These are all very important. And GIRI's strategic aim was based on an improvement in productivity through the elimination of waste and error. But we found over the years that if you use error avoidance as a basis for setting up your business and your project, it helps with a range of other things, including quality and sustainability and the like. We've currently got over 130 members from right across the industry, and this gives us a great base and background for our research and recommendations and proposals. So, quick look at GIRI thought leadership. We have our training. We have 4 training courses now, and we've recently issued our 10,000th training certificate. We have got a framework for the systematic avoidance of error, and which is being run a pilot at the moment with Graham, and we have webinars and forums such as this one. And we share knowledge through our research, which is available on our website. We're very active in communications on LinkedIn, and we've got a library of videos on YouTube. And we provide for networking through our regular members meetings. So what are the benefits of GIRI? Well, productivity. If you're not wasting time and money, you're going to be more productive. 37% of accidents occur during rework, according to research done in Australia. There's no reason to believe it's a lot different in the UK. On the sustainability front, if you're avoiding waste, materials, time, whatever it is, you're going to have a better carbon footprint. And of course, if you're getting things right, your quality is going to be better. And if you're doing all these things better, your outcomes are more predictable, and you and the industry will have a better reputation. We've got a number of working groups. You're familiar with the Technology Working Group, no doubt, because that's the route for these technology reports, that one of which we're launching today to add to our library. We have an insurance working group looking at the impact of insurance and how we can work with the insurance industry to avoid error. The Competency and Compliance Forum grew from our work on the Building Safety Act, and we have been looking at cross-industry metrics with the Construction Special Interest Group of the CQI. So that's me. I'm now going to pass over to John, and he'll take you through the rest of the webinar. You're on mute, John, funnily enough.
Thank you. Yes,
Right.
good afternoon, everyone. I'm John Priestland. I run a specialist independent consultancy focusing on construction tech, and I'm also known for the CTech Club, which is a group, a community of independent innovators in construction. And today we're going to talk for about 35 minutes, introducing the work we've done with the report on AI and error reduction. I've got four friends joining me to speak at different parts of the presentation, so it's not all me. Chris, Jeff, Harry and Mike will be popping up at the relevant stages. And I will kick off by sharing my screen and my slides, and we'll get underway. So hopefully you can see the front slide, artificial intelligence and error reduction, the opportunities and the challenges. This, as Cliff has hinted, is the third report that we've produced in recent years through the GIRI Technology Working Group, which I chair. The first report in November 23 looked at the categories of technology that can be used to reduce errors. It came up with something like 8 categories, giving examples, and was a reasonably conceptual piece of work. The December 2024 best practice casebook in the middle there, that was much more practical. We identified 18 projects that were using technology effectively to reduce errors, and the encouragement was to look and learn from people who are doing it and doing it well. It can be done, it is being done, and you should explore doing it. And then today we're looking at how AI as a specific type of technology, and one that's developing at an extraordinary rate, can answer those questions, how it can help reduce error, but also, as we'll see, how we can help AI itself not becoming a source of error. So in keeping with the topic, I asked ChatGPT. I mean, I do hope you will download and read the report. I like to think that it is well worth your time, and it's pitched at a range that should be accessible to everyone. But some of you will put the report straight into your large language model. So I thought I would help you out. And I said, hey, ChatGPT, please summarize this report in 60 words. You can see what it says on the screen. Explores how AI can reduce errors in construction, highlighting the risks, outlines practical use cases, best practice and guidance on safe deployment. GIRI calls on contractors, software providers and policymakers to adopt assured human-in-the-loop AI strategies. And you can tell that this was written by AI because it's got those long M dashes and Oxford commas. So always watch out for that. If somebody's produced something by AI rather than writing it, there will be those telltale signs. But that's the report in 60 words. So some of you can switch off now and go about your further business. For those that are still staying, thankfully quite a few, a good place to start is to define our terms. Good exam technique at the start of the exam question answer. So here is a definition of error. Any action or inaction that results in a requirement for rework, a requirement for extra work, or produces a defect. And artificial intelligence, here is a definition, there will be others out there, a field of computer science focused on creating systems capable of tasks normally requiring human intelligence, such as reasoning or learning. And to take that slightly more detailed, 2 particular types of AI that are very relevant to construction and therefore to this presentation: predictive AI that uses historic data to forecast future outcomes, trends or classifications, That's typically answering a closed question, is it A or is it B? And generative AI, a type of AI designed to create new content, such as text, images, code, or music based on patterns learned from training data. And so the data scientists would talk about predictive AI being able to group the particular outcomes into class A or class B, projects that are going to be on budget, projects that are going to overrun, and generative AI being a much more broad scatter, with the outcomes being effectively as a very sophisticated version of predictive text. The probabilities at multiple layers are predicting the answer that you want and coming up with increasingly high levels of precision and accuracy most of the time. And we'll come back to that subclause a little bit later. Particular form of a generative AI that's relevant is large language models. These are AI models trained on massive data sets, understand and generate human-like text or other types of data. Whether people are going to use large language models for engineering design, or whether we'll have large design models that understand design more instinctively, is an interesting point, not one for today, but large language models are the here and now. And predictive and generative AI in construction today. Here are 3 startups using AI for construction. Nplan is largely a predictive AI. It uses historic data to tell you whether your project is going to have potential delays and what the risks and deviations might be. Interestingly, they have just introduced a generative AI prediction system, generative planner, to help generate P6 programs in an automated way, drawing on their library of database from previous projects. And then 2 examples of generative AI. Consigli have an autonomous engineer that will automatically create Reba Stage 3 designs for M&E. And Joist are producing a generative AI platform to support bid and tender processes. So if you were or are a bid manager, then potentially generative AI is going to write the bids for you. Maybe it won't be too long before there is a bid a tendering system within clients, and all the bidding people can go off and do something else and leave the agents or the autonomous systems to get on with it. So where are we today on the journey towards AI? As part of the report, we carried out semi-structured interviews with quality and construction managers, with technology providers, with AI professionals to understand their attitude, current use, potential future use, and the barriers. And what we found generally was many firms are using systems such as Microsoft Copilot, which comes within the Office applications. A number, more than half prospectively, have deployed private GPT models, private large language models, to help provide some of the benefits of generative AI, but not having access directly to the models that are wild on the internet to protect internal data. So private GPT models. There are pilot projects focusing on limited tasks such as note-taking and report drafting, and a number of participants in this meeting were trying to get their AI note-takers into the meeting. And most companies have implemented some sort of AI policies aligned both with GDPR and data security. But let me hand over to Chris Johnston from Wilmot Dixon to give a specific example of what they at Wilmot Dixon are doing with AI at the moment. Chris.
Cheers. Yeah. Cheers. Thanks, John. Yes, so Chris Johnson, Enterprise Architect at Wilmot Dixon. Today I was just going to give a quick run through, a bit of a general flavour of how a main contractor is starting to apply AI in our business. I'm going to talk through the approach, a couple of lessons that we've learned, and a small case study to give you the context. So our approach, we're looking at applying a top-down strategy alongside a bottom-up tactical response. On that tactical side, AI really is just becoming part of BAU. It's part of our standard IT processes. We've got AI agents, a part of like our developers' tech stacks. We always review the AI options when we're looking at technology, when we're doing our technology investigations, and new AI ideas. They're just being fed into our innovation framework, where we do a more of a scientific experimental approach for rapidly testing pilots, measuring benefits, understanding the behaviors before wider adoption. So we're testing systems on site like BuildDots, with its AI quality error detection capabilities. On the strategic side, we're considering, we're taking a bit more of a considered approach and trying to identify where these opportunities are. This is more of a high level look at trying to identify new capabilities that can be unlocked by AI. And I see these more around the end-to-end systems architectures where we can use AI to create flow. At the moment, when you look at construction, we've got very fragmented processes. And when we're looking at implementing AI, we need to be very careful about making sure that we don't actually just implement AI to make a crap process faster. So we're hiring a few capabilities in this area, but that's stuff that's we're developing or is still being developed. So moving on to a couple of lessons learned. One around generative AI and data governance. And I think probably a lot of businesses have already come across this. But when we're starting to, us as construction firms, we're dealing with life safety systems. And if we're starting to apply generative AI to it, that has inherent inaccuracies in it. So the other day, there was a POC that was starting to consider using a chatbot to surface our knowledge bases and our corporate management systems. But the team needed to understand that 1 in 10 results potentially could have been incorrect, but they need to be pointed towards using an AI, predictive AI solution instead. But even that's going to have some inaccuracies in it. So the way that we develop our systems, we have to be very clever about making sure that people are competent, and we set them up with a competent man in the middle approach with our systems designs. Another lesson that's learned, we've learned, and I think probably a lot of other construction firms are going to quickly learn this one as well, already have, is around data governance. You're fundamentally going to need reliable information. So we've got a huge source of corporate knowledge that we can't fully tap into yet. Historically, we've lacked some of the good information practices that we needed, so we can't reliably identify the information in a machine readable way to understand what the reliability of it is. So Copilot doesn't know whether it's a work in progress, an early draft, find the final submitted version. But we realize where we are, but there's now helping to make us a strong case for driving a change in the business. So just quickly moving on to a successful case study where we're starting to develop AI. So we're developing an AI chatbot that's using the data from our bid submissions, like somebody else here as well. We see this because it's a published, reliable data set. It's helping to reduce that risk of having reliable information added into that data set. The results that we're returning, they're coming back in our company style and our language, and really it's creating that foundation for a bid, or the bid response research that can take quite some time for the bid professionals really to gather together before they actually can concentrate on the part where they actually add value. So the ease of use of the system's also helping to steer people away from other sources like ChatGPT. So just quickly summing up, that was really just a quick flavor of where we are as a business. We're still in the early stages with AI. We're taking a very experimental approach. We're developing internal learning, and we're continuing to look for our strategic opportunities. Yeah, thank you.
John, you're on mute again.
John, you're on mute.
Thank you. When we ask people about AI today, a common response is it's not yet reliable enough to be widely used, deployed on site, or used in critical decision making. And therefore people are saying, well, it's relatively limited at the moment. People are using it for pilot projects. And yet if you ask people to look 5 years ahead, they're pretty universally of the view that AI is going to be highly influential, fundamentally changing roles, workflows, even the structure of the industry, maybe society too. So we have this today, not so much, but at some point in the next 5 years, big change and big transition, revolution almost. And at what point that bow wave is going to break, nobody knows. But maybe people are a little bit in denial at the moment, or at least at some point that change is really going to come and affect all of us. So what is changing, and why is the pace of change hugely increasing? So this is a slide from Mike Russell, who you'll hear from later, about the almost vertical increase in performance of GPTs, large language models. This ARC AGI score is a test of how close an AI is to human level general intelligence. And it is certainly not the case that these models in all circumstances and all categories are getting close to human intelligence. But that line going from a slow gradual incline to this almost vertical increase is what's significant. What's also driving this huge step change in performance is the sophistication of some of the background models and approaches. So retrieval augmented generation, or RAG, is helping models to retrieve information from external sources at the point at which they're running to improve accuracy and relevance. The context, the understanding in quotes of models of the context is coming from something called multi-context processing, or MCP, and AI agents are producing autonomous systems that will go and deliver tasks and outcomes, planning, reasoning, and acting to achieve more complex goals with minimal human intervention. So these are some of the changes that are taking place in response to and supporting that increase in that capability curve. And month by month, the capability and the breadth of what AI and large language models can do is increasing rapidly. Who knows where it's going to be in 3 months, 6 months, a year, let alone the 5 years of the period I mentioned in the last slide. So it is arguable, this is Eric Schmidt talking in a TED talk in April, that the AI revolution isn't overhyped, it's underhyped. The most important development in the last 500 to 1,000 years. We're entering a new era, it's coming fast and we can't screw it up. The opportunities for construction, but also the challenges, the nature of this talk. So we did a piece towards the front end of the report around the potential for AI in construction. And here are 7 things we think that AI either is or is going to be able to do. It's going to be able to automate drawings and schedules with accuracy dependent on standards compliance. We're going to pick that thought up in terms of accuracy and error avoidance a little bit later. Verification, so tools that can design can check designs and outputs against regulations to reduce errors. Predictive AI for real-time risk management, forecasting delays and hazards to allow early intervention. AI agent streamlining, particularly back office workflows, procurement, invoice paying, finance, bidding, as we heard from Chris. They're already starting to use that at Wilmot Dixon to help with the bidding. So AI agent streaming back office workflows, reducing costs, improving performance. I'm interested in number 5 in particular. We've talked a lot about 5D BIM. If one has an agent for 3D design, an agent for 4D program, and an agent for 5D cost, all trying to optimize and working together, potentially you get a parametric dynamic 5D BIM system that can optimize in a dynamic way across all of those 3. That would be good and exciting. AI can also take a more holistic systems engineering approach, joining up the silos and the fragmented processes into integrated project delivery. And then, given that construction is about real buildings, stations, schools, hospitals, etc., not just reports and designs, we need stuff that can do pouring and carrying and lifting and all of that. So the integration between AI and robots for physical delivery, that's going to be an exciting additional part of where the AI revolution is going. But you might be sitting there saying, John, that's very good, but that's very general about AI and construction. This is GIRI, and I think you're supposed to be talking about error. And I'd say you're right if you were to say that. And so I take us back to the report that Cliff mentioned from 2016 in his opening remarks, and these 17 root causes of error from the original GIRI report, ranked from inadequate planning, late design changes, poorly communicated design information, through to poor site conditions and access. So those 17. Rather than working with those as an input, we actually chose to work for this analysis with a shortened version of those 17 root causes that came out of some work that HS2 did and kindly allowed us to work from. So these 9 categories of error on the left-hand side link back to the 17 root causes from the GIRI report, poor planning and design, lack of skills and training, poor communication, etc. And what we did with those is we looked for the opportunities for AI to help and support for each of those. So you can see for poor planning and design, the opportunities are clash detection, AI-driven identification of design conflicts, diagnostics, a shift from checklists to real-time issue detection, and so on. I won't go through and read all of this out to you. It's in the report, and I hope it will be worth some time and investigation. But you can see for each of these 9 categories of error, there is a significant contribution that AI can make, and quite a diverse set of things that AI can do. Many of the words here are used once on the screen. It's not as if the different 9 categories are covering the same summaries. They're all different and distinct, and there is a lot there. Point being, we have a lot of positivity and optimism around how AI can help reduce error. What we then did is we plotted these 9 categories on a 2x2 or 3x3. Left, right, we've got progress to date, and up, down, we've got impact of error reduction. And arguably, few of these categories have progressed very far so far. Some of them are in the low, some of them in the low, medium. And the 4 that have arguably the best potential impact on error reduction are poor planning and design, inadequate project management, quality control and compliance, and human error. And distilling all of those various contributors, the different ways in which AI can help those 9 categories, and particularly these 4 which have the greatest impact, the 5 key ways in which AI can make a difference, make a contribution to error reduction, are these 5 on the right-hand side of the screen: insight and prediction, automation and assistance, monitoring and verification, communication and collaboration, decision-making and control. So the future's bright, the future's AI for error reduction, but what are people doing now? So I'm going to hand over first of all to Jeff Carmichael from Collimate, and then hand over after that to Harry Yates of Build Prompt to talk through briefly what they're doing in terms of products and systems and project delivery, specifically using AI for the purpose of reducing error. Jeff, if you'd go first.
Sure thing. Thanks a lot, John. Great to be here, everybody. So my name is Jeff Carmichael. I'm the co-founder of Collimate. We're actually launching a brand new product called Spec Helper. But in terms of error reduction, I think a lot of people that have worked in the industry will know that some of the best advice that you can get in the construction industry is that you should read your specification. Ideally, cover to cover, assuming you're kind of working on every scope of work in there. But unfortunately, that's also some of the least followed advice in the construction industry. And this is set to become an even bigger problem with some of the conversations we're having today with those ChatGPT for construction. So whether it's Microsoft Copilot or something that you've built internally, or some of the other commercially available tools, you can see on this graph here that hallucinations are very much still a problem. As somebody else mentioned, 1 in 10. 1 in 10 of the times it's going to be wrong to at least to some degree, and that's true kind of from this. You can see from this benchmark report here. The picture is slightly out of date, but I checked just the other day, and the levels, whether it's Grok 4 or anybody else, that 10% hallucination rate is still holding strong. So, and not only that hallucination issue, but also just the way that people could become reliant on these systems. So it can actually kind of lead to a worse mental model of the project. Like those people on the ground that are kind of knowing where everything is going, if they become just kind of too reliant on prompting, then that can cause a lot of errors. So whether it's that mistake, if they're getting a prompt and getting the wrong answer from a chatbot, or just kind of not understanding something as well as they should, just not having that ability to read the spec or read the drawings, that sort of thing. So our approach to that is with our new product called Spec Helper. So we aim to both give people the help that they desperately want to read their specifications while still keeping them in the driver's seat. So I don't have any screenshots of it here, but if you're very interested, feel free to check out our website. We really want to keep kind of humans in the loop and working side by side with the AI as opposed to just kind of letting the AI go.
But
have that more kind of collaborative approach. That's it for me. John.
But thank you. We'll pick up a little bit more around hallucinations, what we mean by that in a couple of ticks. But thank you, chatbots and specifications. And Harry, you're up next from Build Prompt.
Great, brilliant. Cheers, John. Thanks, everyone. Yeah, it's just I'm Harry. I'm the founder of Build Prompts. We're a software company that focuses on supporting companies across the built environment, particular focus on infrastructure, construction, and real estate, supporting with automating and semi-automating the manual processes that happen across our industry every single day that really kind of set back time and push forward onto these kind of issues with projects running late and over budget and all these kind of cliches that we're stuck with as an industry. We focus on having a team that really knows the industry well, and pairing that with kind of leading AI talent. We saw an opportunity to actually bring advancements from other industries, particularly the aviation space, which had kind of huge areas of focus for many years, particularly around kind of organizations like Airbus, who are utilizing AI to instantly provide the right data to the right person, pilot, team member, stakeholder, and so on. I think a key thing to be aware of and a key differentiator is that we all know there's a digital lag here, but I think it's all too often overlooked that actually construction and the industry that we're all in is really tough. So we're not building cars, there's not machine-made products yet. And so, people are putting these materials, processes, and programs together in various different ways. And so there's not kind of a one-size-fits-all way of solving these problems with technology, but certainly AI is probably the first kind of leading edge offering that can help kind of bridge that gap. The pressures that's there across our industry means that, companies are pressured to adopt tools, maybe they're not the right fit, and ultimately that has a knock-on effect that can lead to lack of adoption and, fragmentation, which is kind of key area that we look at. And so what we did was that we kind of saw an opportunity to utilize organizations ideas where they wanted to optimize different parts of their supply chain, different parts of the way that they work as organizations. And we saw that kind of covering three key areas. One is the initial kind of compliance area, understanding data that they've got around health and safety, the standards, the lessons learned, and then how that ties then to the handover process. So working with organizations to ensure that when they're receiving assets that have been built for them, for example, or they're delivering assets, that they're doing it in the right way, that they're meeting the requirements, and they're not spending, huge amounts of time kind of validating and verifying information that perhaps could be done in seconds as opposed to weeks. And then once that's all done, how you optimize that, how you take, the leases, the maintenance information, and so on, and utilize that in a way that can drive that forward. And so I put a couple of case studies down here, but I think a super relevant one is our work that we're doing with HS2 directly, and then also through their supply chain. Me and John have had quite a few conversations around this, and I'm more than happy to answer kind of more questions on, how this aligns to maybe where we see the industry going. But ultimately, HS2, very complex project, lots of requirements set for delivery. And so when these assets are being delivered, the requirements have obviously changed. The world's a different place than what it was. The resources that are in place now are not available now or are different. And so it becomes very difficult to manage the delivery. And so Build Prompt automates what was previously taking around 2 weeks to assess the delivery data from an asset down to, around 35 seconds. And what this did is had a knock-on effect where the contractors then delivering the project had all this data around non-conformance and safety and so on that they wanted to utilize to ensure when they look forward at their program that they can optimize and not make the same mistake twice. And I think that really that is the key thing for me is using AI is that how you can validate ROI and where your business can do better is how you measure how you don't make the same mistake twice. And this is not a magic wand, and we're certainly trying to avoid adding to the noise that's there. We try to be super focused on the problems that our clients are facing. And so if you think about how a contractor like EKFB is delivering HS2, all the data they have around concrete, non-conformance, issues with previous delivery that happen on any project around the world, how that can be used to compound that data to look forward, detect the patterns, and then understand where high risk areas are that they're likely to make the same mistake twice. And so, yeah, that's a big focus of us, and it's been great. Actually, we got a lot of that work from originally the CTech Club from John, bringing that kind of offering forward. And it's really just people getting creative around what is the problem, how they measure an ROI, starting small and then scaling up these case studies and use cases, which I think is super critical.
But starting with the problem. Thank you, Harry. That's great. So you heard it a couple of times already, hallucination, and the fact that AI makes mistakes. And it makes mistakes when you're really not expecting it to do so. And sometimes it makes really bizarre, odd mistakes. Where did it get that from? So the definition in the report on the screen here, an hallucination is when an AI system produces information that is plausible sounding, but factually incorrect or nonsensical. And the headlines on the screen show that hallucinations are real, whether they're getting worse or not. But there are all sorts of examples of citations in court hearings that have been fabricated. And in a high hazard environment like construction, that's not something we can countenance or allow. Going back to the feedback from the people we spoke to, trust in AI was a big issue. So Mike, hand over to you for this slide and the next slide. You're an expert on this. AI makes mistakes, so how do we prevent AI from being a new source of error?
Thank you, John. Yeah, so the word hallucination has popped up a few times and we're all familiar with it. There's actually a bit of nuance around hallucination as well, because some of them are very subtle and hard to pick up. Things like just getting a date slightly wrong or a number slightly wrong, which is the kind of thing that you can easily miss. So on to what we do as a company and kind of how we focus on reducing errors, what we do. The system we build is about assurance. The point 4 here, assurative AI. It includes human in the loop, which is a really important thing that John's mentioned has been resonated, that importance of having people as part of this process. We all know that AI is very, very powerful, and we all know it's getting smarter and smarter, and that increases, it's basically exponential right now. But it still does make silly kind of school child mistakes. So there are a couple of things which can help to reduce that, one of which is, human in the loop. The other one is things like chain of thought reasoning, which is actually built into a lot of models now. So the reason the models have got so much better recently is they started to produce multiple solutions to problems and then rank them and then kind of optimize, check that they're correct. And this is really what enabled the models to go from a plateau to a vertical. So it's kind of a slightly different architecture, and it makes us building systems slightly easier, because before we'd have to kind of build that ourselves. Now that's kind of built in. So as we are building AI systems that use LLMs, there's a trade-off between how much of it you prompt yourself and how much of it you actually allow the LLMs to do, because they are getting more powerful. If you take that away from them, you kind of own that, which is good from an observability perspective, but from the perspective of advancements coming at the rate they are, it's not so good. So that's kind of a balancing act to do. But focusing really on how you can reduce errors and ideally get rid of them completely. What we do as a company is we build an assurative system. Thank you. So similar to what Harry was mentioning about collecting information, the way we do this is we build this into knowledge graphs that have relationships between information that makes things very, very searchable. And then we have specific AI models that understand the architecture of this information, and combine that with the ability to understand the engineering aspects of standards and project information and lessons learned, and to combine that with engineering know-how and the ability to automate some fairly sophisticated processes. You end up with a system that can do some quite sophisticated work. Things like, moving towards design reviews, one of the points John mentioned about that, taking a report and saying, does this comply with standards? That's a very complex process that would usually be done by a human and still has to some degree. But really what we do need for systems to be truly useful and to kind of augment what we're doing is the ability to understand those project requirements, be it standards, employers' requirements, specifications, be able to cross-reference with them, bring that information into workflows and have the human at the center of that in a way that's easy and accessible so that you're not being replaced by an AI, because that's really quite infeasible to do that. We know how complex construction is, but being augmented. So the things you don't really enjoy doing, such as cross-referencing, such as looking for information, such as building workflows, building calculations. This isn't really fun stuff to do, but whiteboard thinking is fun. Thinking about the problem spaces that are fun. Having, a small army of assistants that can help you with complex processes that are observable, that's actually quite fun. So really that's what we do. We structure information, we make systems that can retrieve that information, and we provide then things that can do stuff with that information in a way that is auditable, because at the end of the day, that's really the key to it. It's being able to have human and AI auditability to, one, catch errors before they happen, but two, if there is something wrong down the line, you can follow those processes from what was the output, what was the processes used, and what information was used and why. So yeah, that's us in a nutshell.
Thank you, Mike. Mike Rustle from Informatic there. This is my last slide, but I'm going to take a little time because it's the payoff for the 32 pages that preceded in the report. Recommendations or suggestions as to what contractors and others in construction technology providers, GIRI itself, should do. So contractors and others working in construction should focus AI investment on high impact error sources. We've identified some of those in the report, and so the most likely, most useful in terms of impact for error reduction. Building on what Mike said, conduct risk assessments before deploying AI tools. There are certain tasks that you really wouldn't want to use AI for, certainly not at the moment, potentially never. There are other tasks which are less safety or project critical where AI is much more appropriate. Embed assurance into the AI workflows, such as chain of thought reasoning, human in the loop validation, and assurative AI, so that where you are using AI, you are working as far as possible to minimize the risk and impact of hallucinations. And then establish internal policies and safeguards to prevent unauthorized or inappropriate use of AI. And do you know what systems your staff are using? Are they putting confidential company or client information into LLM systems where the information goes straight back to goodness knows where? How do you know? And are there clear rules to make clear that that's not something that can be tolerated? For software providers, we argue that error reduction is an excellent use case for the development of AI systems. There is a lot to go after in terms of the 21%, the 21 billion lost in direct and indirect errors every year. So software providers come and develop error reduction systems using AI as a priority in your product roadmaps. Again, develop verification tools to assure those outputs if you're producing things from generative AI, and integrate AI into lessons learned and quality management systems. They're great early examples of how AI can support and improve existing tools. The idea that a lessons learned system, which is required under ISO 9001, might just be a spreadsheet or a list with no context and no continuity. AI can bring that to life, joining together the errors that are similar, the common causes that are similar, and making sure that the right people in the organization are informed at the right time. So lessons learned and quality management can be great specific early examples of the development of AI practically in terms of error reduction. And Cliff, I speak for GIRI. If you want to step in and say no, GIRI, as part of this report, GIRI itself is promoting AI for error reduction across the sector. That's with companies, but also with software providers, saying AI is good news for error reduction. Please come and develop the systems. Please use it. and the Technology Working Group, which meets once a month on the last Friday of every month via Teams, and has been responsible for developing the three documents, of which this is the third, which I showed at the beginning of the presentation, will be there to bring together the technology providers and the users in quality management and design management, etc. So GIRI will promote AI for error reduction across contractors and technology providers. We will expand the best practice casebook that we published last November to include some AI examples so people can learn and see where AI is working well. Chris has given us some examples with Wilmot Dixon, but we will put that together for late this year, a sort of reissue of that, but an AI compliant, AI enhanced version of the casebook. And GIRI will be an advocate for safer, assured uses of AI and champion ways of doing this for construction. And this GIRI philosophy of everybody working together for better outcomes and lower errors is a very powerful one. Now we can add AI into that philosophy. And a final thought, but I've got something in front of my screen. A final thought: AI will not solve construction's problems alone, but used wisely, it could become a powerful force for good to help reduce error and improve outcomes across the industry. I hope you will dive into the detail, some of the detail of the report, and we'll be very interested in your feedback. But for now, we've got just a few minutes available for questions.
Okay, thanks very much, John. Before we just go to the questions, I just want to reflect on how important this is. I mean, I've been in the industry now for 45 years, and I've been required to make a lot of decisions along the way, from when I was a junior engineer to being an executive responsible for profit and loss. You're constantly making decisions. Somebody's coming to you to make a decision, and the thing about decision making is you have a variety of options, and you're trying to work out which is the best option. The thing about AI is it's bringing to the decision maker, at wherever they are, at whatever time, the opportunity to get more information more quickly and more relevant, and it's got to be going to be making a difference. And I do highly recommend, I would say this, wouldn't I? But this report is really good. So have a look at it, have a read through it. I've read it cover to cover. It is great. Anyway, sorry about that. Had to say it. Questions coming up in the chat, which is great.
So, Cliff, can I suggest, in terms of the questions, we've got some questions in the chat, and then we've got some hands up. So I was going to come, if I come to you, can you feel free to unmute yourself and ask your question? I think that's probably the easiest way to do it. So, okay. Douglas, you've Douglas Lockyer, you've put a couple of questions in the chat, so maybe you'd like to fire a question at our panel.
Okay, if you can hear me, then the first question relates to the carbon emissions associated with AI usage. And I suppose my question is predictive AI the first thing to go to rather than the generative AI, which presumably would consume far more carbon? And second part of that question is, should organisations declare what their carbon consumptions are associated with AI use as part of their Scope 3 carbon emissions?
Well, you're right. Every time we put a query into our LLMs, it's using something like 1/4 of a litre of water. And there are various predictions as to what proportion of the power consumption on the Earth is going to be used for AI and data centres. And I think it was Eric Schmidt who predicted it would be 99% of all power produced would be used for AI and data centres. Even if it was 60% or 30%, it is huge. So thinking a little carefully around how you use AI, and that there is an environmental cost as well as perhaps some small monetary cost. There are some interesting systems. I went to a presentation last Tuesday by an organisation called Braintree, who claim to have a much more ecologically friendly AI system which can crunch data much more efficiently. So that maybe is something to start thinking about around your choice of LLM. In terms of your specific question around Scope and carbon, and whether organisations should start calculating it. I'm afraid that's beyond the knowledge of this humble construction tech person. But the carbon rules are clearly complex and important, and certainly this is going to start becoming a material factor in how much organisations are using in terms of carbon and greenhouse gases. It's a great question.
Thank you. I'm going to come to Roxy next because we've got a few other hands up as well. So Roxy, if you've got a question, could you unmute yourself?
Hi, yes, thank you. So actually, from my understanding of my background in data science and working on GIRI for Try as a business analyst, so the major challenge that I see for leveraging AI in construction is messy data. The inconsistent data. And I've been spending for more than 1 year to clean the data. So I think data is lifeblood of AI. So not having that kind of consistent, reliable data set, we are going to nowhere. I think like the fact that I didn't see in the slide, the biggest challenge is like fragmented data. So not only because the fragmented nature of the construction, but also because the way that they capture the data is also not consistent way, like not aligned with the standard. So I think there's a really big challenge in construction that we need to talk about more, how we can clean the data to then we are able to develop the AI. So yeah, John, what we can do about it?
Yes, good clean data is always a good thing. I think AI is also playing a major part in helping us clean data. So one of our CTech Club members is a company called Hopper.ai. It is cleaning the data in terms of IFC classifications for BIM models. Humans make mistakes, so that one person will type in beam, B-E-A-M, another person will type in beam, misspell it, B-A-E-M, another person will type in sort of horizontal structural member, and the Hopper system will just go and look at it and go, it's a beam, it's this classification. And I think we shouldn't underestimate the power of AI to make considerable inroads into that, cleaning up data and drawing insights from less than perfect data sources. And Harry, this is some of the stuff that you're doing with Build Prompt. Do you want to give a quick further answer to Roxy? I think you're more expert on this.
Yeah, I do think that it is definitely a big area of focus. I think that it will become less of an area of focus, but it's like an inevitable journey that the kind of the world going through in terms of using AI. It's actually, like him or loathe him, I was reading an interesting article from Elon Musk recently about how the actual, in terms of general large language models, there's no more human created data for it to be trained on. And so now the advancements that's come through with Grok 4 is very much focused on creating synthetic data. So I think it's going to get really interesting is where, yes, we've got so much more construction data to look at and start utilizing to create more accurate prediction models and utilize RAG in a way that is beneficial to the industry. But also I think that, like John says, the tools to enable the labeling is going to be super important. Most of our clients have problems with standardization. So we can have lessons learned in the same organization submitted in 3 or 4 different ways. And that's very common. And so the process for us becomes around how we standardize that. And that's a big part of the engine of Build Prompt. What we do is we built a framework that goes, okay, here's lessons learned from 3 different areas. How do we standardize that into one thing automatically, validate that with the client, and then enable that to be scaled up to be used across that organization and do that in different kind of facets of the problems they're trying to solve.
Thank you. Mike, you've got your hand up. You want to fire away? You're still on mute. Okay.
Hi. So thank you. We have a lot of massive documents in construction, and a lot of people struggle to read everything and get a thesis. So the value there is massive. I was wondering if it might be already done, and I'm not aware if any models are already trained on engineering standards, and what would be the impact beyond design? Because if an LLM or an engineering model can find a solution within milliseconds, that could be a nice step forward. But I'm wondering if that also has like an impact on liability, because currently it's the engineer's job to make an interpretation on the standards.
Mike, I'm going to throw that straight to you. Obviously, we've got a plant here. Mike, you take that one.
Yeah, thanks. So the system we build is designed for standards, pretty much specifically. And you mentioned the word train. So you can train models around the standards text. Some bodies give their standards away for free. Others, it's behind a copyright wall. So there's issues with that. But notwithstanding, yes, you can train models on that, but you can also train your system around that. So your kind of retrieval system, which is I think that's a better approach, at least initially. The reason why is that models are updated so often that you train a model and it's already obsolete in a few months' time because something much more powerful comes out. Also, as you train models, they forget other things, so you have to really focus them. So it's good that you have trained models within your overall process, but the way we like to do it is we break standards down into basically the requirements and make that all searchable, build the structure around that. And then when you ask something, our retrieval system is able to identify what you need and basically bring that to you. Moving on to the question of liability, it's complex. I think that realistically, the liability has to sit with the engineer, and we have to make it easy for that liability to be very clear as to what we take as a company and what you take as an engineer, and to make the system transparent so you can see the data, you can see the process, you can see the output. Therefore, you have something you can review and you can query and you can see. Because the more we obfuscate from you, the more risk we take as a company. So if we make everything clear and bring you information, allow you to query that, allow you to use that, and can demonstrate how that's being done, it's up to you really to check that, because you have everything you need. And really that's the approach we take, because I think fully taking responsibility for design outputs in that way is from an insurance perspective, who's going to insure a startup for that kind of liability? I don't think we would be able to possibly do that from an insurance perspective. And there's also other areas. So that's all emerging, but I think that's the process we take with that.
Thank you. I'm going to try and squeeze in one more question, and then any questions we haven't been able to get to, we'll pick up after the session. So Chris Parry, you had a question about ISO standards.
Yeah, it's a very, very quick one, because obviously I got to drop off in 2 minutes as well. How much credence was ISO 42001 taken out of this review?
So I think we've covered the main dynamics from 42001 for error reduction. I mean, it was that slide where we talked about structured risk management, we talked about human in the loop, we talked about chain of thought reasoning and the sort of transparency. What we haven't covered, and you can argue whether this was right or not, was sort of ethics and bias. Perhaps that we should have given a little bit more regard to that in the report, but equally we're talking about engineering outcomes rather than stuff to do with people and groups of people, etc. So I think if we look back at 42001, it's pretty much all in there, with possibly the exception of that last one. But it's a great question.
Great, thank you. So I think we're just going to wrap up now. So I'll hand back to Cliff and John. As I said, any unanswered questions we'll follow up with outside the session.
Well, in a wrap up, I just think it's great that we've had such a good response to the webinar and the questions raised, and I've read the ones through in the chat box as well, which are some of which are quite challenging. So we will do some work on that after the closure. But I just want to thank everybody for coming along today, and particularly to our presenters who've joined in. And John knows I think he's great. So well done, John. Another great report. Thank you very much.
It's great working with you, Cliff. And
mutual.
GIRI is such a cut-through philosophy. When you're working in construction tech, nobody comes back and goes, you know what, John, I think we should have more errors. Nobody says that. So it's a cut through, and the philosophy and the quality of the people involved in GIRI is first class. Thank you to Susan for sorting all the arrangements out for today. Susan, were you able to pop the link to where people can get their hands on the report in the chat? There's a couple of people who are going, where are the references for this? And the answer is it's all in the beautifully produced 32-page report. And I'd also like to thank Chris and Jeff and Mike and Harry for coming along. Sounds like a boy band, doesn't it? For coming along today and singing and dancing and doing all their stuff. And over to you to go and use AI and come back again and contribute to a technology working group and the case study document that we're going to be putting out later in this year. Let's see how well and how fully we can reduce errors and avoiding AI itself being a source of error. Thank you and goodbye.
Bye-bye.
Thank you.
Thanks.
Thank you.